Hello everyone, welcome to today's class. In this lecture, we'll continue with another topic of integration, that's partial fraction. Okay. Again, the integration part will not be tough. It's the partial fraction which is tough, and how will you identify it's a partial fraction or not, and when the partial fraction is applicable or not. Okay. So I've given like 1, 2, 3, 4 forms. That's it. You have to understand these 4 forms. Okay, and the idea is that remember, like we splitted the product to sum in trigo. Same thing we are doing with algebra, but they are in the denominator, and still we are able to write this as like suppose this is the first expression, x minus a, x minus b in the multiplication. I can write something upon x minus a, something upon x minus b. If I can write this and integrate, it's very simple because I can do the integration of 1 minus x minus a, x minus b, that's log. Okay. The key point is when the partial fraction is applicable as such. So remember, you will have some numerator also. It's not necessary that every time you can apply a partial fraction. You will have some numerator, you will have some denominator. The degree of the numerator should be less than the denominator. Means how much is the degree here? Power 1, so total power 2. When you multiply this, you get a quadratic now. So that the degree of numerator cannot be 2 or more than 2. It should be always less. Means either it should be 1 or 0. Similarly here also. Now x minus a, x minus b, x minus c. Okay. I can do partial fraction only if whatever is present in the numerator has a degree less than 3. Because 3x's are there, no? Okay, means 2 or 1 or 0, that can be the degree of the polynomials. Okay, so always this rule is applicable. Now let's look at format one by one. Okay, first, second, third, fourth. The first form and the second form pretty much, I'll say they are same. It's just that if you have something upon some px is some numerator, we don't care as long as it has a degree less than the denominator, and it is x minus a, x minus b. I can write this as a upon x minus a, b upon x minus b. If I can find a and b, I can integrate easily. Same idea is with this also, x minus a, x minus b, x minus c. I can write this as a upon x minus a, b upon x minus b, c upon x minus c. Okay, and again integration will be done. Let's see from the question and understand how this works. Okay. All right. Look at this question. Clearly it matches with your first form, x plus 1, x plus 2. So I can rewrite. Let's check whether the partial fraction is applicable or not. What is the degree in numerator? No power of x. That means degree is 0. What is the degree here? Degree denominator is 2. Total degree. So yes, degree of numerator is less than degree of denominator, so partial fraction applicable. Okay. Next step, I can forget about the integration part. Okay, this can be written as a upon, in fact let's forget about this. Write down 1 upon x plus 1, x plus 2. Okay. The task is to write this as a upon x plus 1 plus b upon x plus 2, and you have to find a and b, or c is there. Okay, x plus 1, x plus 2. Now in order to find, what you are supposed to do in general, you are supposed to create an equation, then compare left side, right side, and create equations, 2 equations in a and b, and solve them. That's a lengthy process. Look at the short variation of it. X plus 1, x plus 2, 1. This is a, x plus 2. This is b, x plus 1 upon x plus 1, x plus 2. Now what I'm showing is not correct directly from mathematical point of view. Okay, I'm cancelling this, but the moment I cancel it, I'm assuming that x should not be minus 1 or minus 2, but next step I'm going to do that only. So right now focus on this simplicity, don't go for the background working, that why we should not cancel this or not. Okay, so this is the equation, and now you have to, what you can do is literally compare left side and right side and solve the equation, or get a and b with a shortcut. What is that shortcut? How does that work? You put value of x something so that one of the coefficient becomes 0. So if we put x as -2, this will become 0. So what will we have? 1 is equal to, this will become 0, -2, and this will be equal to b into -2 plus 1. So which gives us, this is -1, so b as -1. As simple as that. And put this time, try to make this coefficient 0. So put x as -1. Okay. If we are putting, remember right now this is only 1, but if some expression of x is there, so we'll put the value of x here also. So 1 is equal to a into -1 plus 2, so that gives you a as 1. Now we know a and b. That means this question has become, what's a? 1 upon x plus 1 minus 1 upon x plus 2. Okay, now this question has become this dx, and I think we can directly write down the answer. So let's slightly shift this. Is equal to, this will be log mod x plus 1 ax plus b format minus log, because 1 by x integration is also log x, and so 1 by x plus 1 integration will be 1 by mod of log x plus mod of x plus 1 mod x plus 2 plus c. You can combine these two log of x plus 1 upon x plus 2 plus c. Okay, that's the answer of this question. Okay, let's look at another question. Now same idea, pretty much same idea, is just that if you look at this question, okay, so in this the problem is that the degree of numerator is 2, degree of denominator is also 2. If both numerator and denominator has degree 2, we cannot apply partial fraction, remember that. So cannot apply partial fraction. Okay, so in order to do that, what we have to do, we have to literally divide this two polynomials. Okay, so if we divide this, let's divide it. You can normally divide this x square minus 5x plus 6 divided by x square plus 0x plus 1. You can do normal division also. I'm not going to do that. I'm going to adjust this slightly. It's faster that way, but you can do this by this method also. Okay. Or what I'll do, I'm creating x square plus 1 is there, na? So I'm writing minus 5x. So I have to write plus 5x in the numerator to adjust. I'm writing plus 6, so I have to write minus 6. Okay. X square minus 5x plus 6. Okay. So now adjust it, divide this along this, so it will be 1 plus 5x minus 6n minus 1n minus 6 minus 5 upon x square minus 5x plus 6. So this is the integration now. Okay, 1 we can integrate easily, and this term, now you see, let's take one more step actually, 1 integration of 1, and this 5 if I take common, x minus 1, denominator you can split, x minus 2, x minus 3, okay, dx. Now if you can recall something from the last lecture, this is linear, denominator is quadratic. Yes, you can go for the standard form. Okay, you can go for d by dx of quadratic plus b, something like that, na? But partial is much faster than that. Okay, so if your quadratic equation in the denominator can be splitted in two parts. Okay, like the first question also, I didn't discuss it here. This is also like quadratic, na? But we didn't do the standard form approach. We didn't make perfect square. Rather, we preferred partial fraction. Why? Because partial fraction is much faster as compared to your creating perfect square and using standard formula. Okay. So same thing here. So let's do partial fraction on this first of all. 5 bracket x minus 1 upon x minus 2 x minus 3. This time degree is 1, denominator degree is 2. So applicable? Yes. So I can rewrite this as a upon x minus 2 plus b upon x minus 3. And now I have to solve for a and b. So let's solve. 5x minus 1 upon x minus 2 x minus 3, a x minus 3, b x minus 2 upon x minus 2 x minus 3. Okay. Cancel. And now we don't create equations. What do? We use the shortcut by putting the value of x. Put x as I want to make a 0, so put x as 3. So that gives me 5 into 3 minus 1, 2. So 5 into 2 is equal to b into 3 minus 2 is 1. So that gives us b as 10. Okay. And if we put x as say 2, so this will become 0. So 5 into 2 minus 1 is 5 is equal to a into 2 minus 3 is minus 1. That gives us a as minus 5. Okay. I got my a as minus 5, b as 10. Okay. So now let's get back to the integration. Integration was 1 upon 1 plus, and then this term 5 bracket x minus 1 x minus 2 x minus 3 na? So that was a upon a is minus 5, so minus 5 upon x minus 2. I have taken a upon x minus 2 plus 10 upon x minus 3. And now it is very simple, just integrate. What is integration of 1? X. What is integration of 1 upon x minus 2? Keep minus 5 as it is, minus 5 log mod x minus 2 plus 10 log mod x minus 3 plus c. Okay. That's the answer. Okay. All right. So that was the thing that you have to take care when the numerator and denominator degrees are equal or even more. Suppose it is more, so still you will do the same thing. Okay. Now let's look at another form. Okay. So two forms we have done only one form so far. I'll do the second form question first. We'll do this later. I have to get a question now. Let's take this. The second form, again same thing. You have to check first of all before applying partial fraction. Degree of numerator 1, degree of denominator 3 terms, so 3. Okay. So a upon x minus 1, b upon x minus 2, c upon x minus 3. Take the LCM. A into x minus 2, x minus 3, b into x minus 1, x minus 3, c into x minus 1, x minus 2 upon x minus 1, x minus 2, x minus 3, 3x minus 1, minus 1, minus 2, minus 3. Cancel it. Now don't create equations, just put values of x. Let's put x as 1. Okay. The moment we put 1, the left side becomes 3 minus 1, that's 2 is equal to, if we put 1 here, so a into minus 1 into minus 2 plus this will make it 0, this will make it 0. So b and c both become 0. Okay, the coefficient becomes 0. So we get directly the value of a as 2a is 2, so a is 1. Okay. Now put x is equal to 2. Okay, because that will also create 0. Let's see. So if we put x as 2, so 3 to the 6 minus 1, 5. 5 is equal to, the moment we put x as 2, a, the coefficient of a becomes 0. This b we can find now. 2 minus 1, 1. 2 minus 3, minus 1. Plus c, again x minus 2 is there, so 0. So this gives us b as minus 5. Now put x as, what factor is there? X minus 3 is there, so let's put x as 3. Also it will create zeros. So if we put 3, so 3 3 is 9 minus 1, 8 as 0, then again 0, 0 plus 0 plus, this time you will get c into 3 na, so 3 minus 1, 2, 3 minus 2, 1. So now what is the equation you got? 2c is equal to 4, so 2c is equal to 8, so c is equal to 4. Okay, so not the answer, but yes, this. Now if the question is of integration of this, 3x minus 1 upon x minus 1, x minus 2, x minus 3 dx, I can rewrite this as, what's my a, b, c? A is 1 upon x minus 1, b is minus 5 upon x minus 2, c is 4 upon x minus 3 dx integration, and I think it is pretty straightforward. Log mod x minus 1 minus 5 log mod x minus 2 plus 4 log mod x minus 3 plus c. Okay, so partial fraction, actually I'm writing and explaining you, that's why it is looking it's lengthy, but from making perfect square it is much faster. Also you cannot use that idea in x minus 1, x minus 2, x minus 3 in multiplication, so partial fraction is the only approach. Alright, now let's get back to the question for third form. So every form we'll discuss one question and then variations of it. Okay, this is the question. Again, degree of numerator is only 1, x raised to power 1, and denominator as x square plus and multiplied by x, so x raised to power 3. So yes, less of course. So yes, partial fraction is applicable, but look at this, there is a square on it. Okay, so some factor is being repeated. So this is the form, third form, whenever x minus a whole square is there. So you write down this as a upon x minus a, b upon x minus a whole square, means both terms will be written, x minus a as well as x minus a whole square, and c upon x minus c. Okay, so the partial fraction form, see, you have to learn only the form, that it will be a upon x plus 1 plus b upon x plus 1 whole square. So you have to write x plus 1 whole square both terms, and c upon x plus 3. Okay, again order does not matter, whether you write a upon x plus 3 first, or means instead of c you have written a upon x plus 3, then b upon x plus 1, c upon x plus 1 whole square, doesn't matter. Okay, this a, b, c are random values, but that will be generated with this expression. No. Okay, now let's create equation before actually doing partial fraction. Let's take LCM, and we know that LCM is going to be cancelled. So a multiplied by x plus 1, x plus 3, b into x plus 3, c into x plus 1 whole square. That will be 3x minus 2. I'm not writing denominator because this is going to cancel. Okay, now start with the shortcut. Put x as first of all minus 1, Let's see which one gets 0. Let's put it 3 into -1, -3 -2 -5 is equal to, this will become 0, C will also become 0, so 0 and 0, and only B will be there, B into -1 plus 3, that's 2 plus 0, so that gives you -5/2 as your B. Okay, next is you put now x equal to -3, that will also generate 0 something, -3, so -3 and -9 -11, so -11 is equal to, this A term again becomes 0, B term also becomes 0, C into -3 plus 1 -2 whole square is 4, so C is coming -11/4, that's your C. Okay, so by taking both x as -1 and -3, you're not getting the value of A. Now how will you get the value of A? Okay, right now the idea was to get zeros because it was easier to solve. Okay, now for that what you can do is you can put any value of x apart from these two, because otherwise A will become 0 na? So now I'm going to put any other value, so I'll put x as 0. I can put anything, 2 also, 3 also, 4 also, anything you can put, but I'm taking the simple one, 0. This time none of these expressions will become 0, so 3 into 0 -2, that's -2 is equal to 0, so this will become 3a, this will become plus 3b, this will become plus c. Okay, now you already have the value of b and c, put it here, solve for a. Okay, what do you get? You get the value of a as 11/4. You can solve this on your own. Okay, put the value of c and this in this equation, and you get the value of a. You'll get a. Once you get a, I think after that it's very simple. Okay, we have to integrate. I'm replacing the value of ABC. A is 11/4, B is -5/2, C is -11/4. Okay, now we have to integrate. Okay, dx. Okay, so 11/4 is a constant log mod x plus 1. Okay, this one is x plus 1 whole square, so use ax plus b format. What is 1/x square integration? That's -1/x, so same thing, so minus of -5/2 plus 5/2, 1/x will is actually x plus 1 here, minus 11/4 log mod x plus 3 plus c. Okay, maximum you can do is combine this both of these term first and last. We can combine because both have same coefficient, so we can combine this. 11/4, subtraction is there, so log x plus 1 upon x plus 3 mod plus 5/2 bracket x plus 1 plus c. Okay, done. So remember, the shortcuts are very good as such. If you have only x minus 1, x minus 2, x minus 3, if some whole square is present, then it will take one more slightly longer step, not too much lengthy, I'll say. Okay, and you can put anything, literally. You don't have to worry about making something 0, but remember to find a at the last because it will require b and c. All right, we are done with this. Now let's look at another question. Okay, now it is x square upon x square plus 1 x square plus 4. Okay, for the time being, you might think partial fraction would be applicable if only x square was not present, only a single variable was there. Okay, x was there or y was there. So for time being, let's assume, I'm not doing the substitution, I'm assuming, okay, assume x square is some y. Okay, this is not substitution, remember that. So this will look like this, na? Actually the expression y upon y plus 1 y plus 4. And if I tell you that is the partial fraction applicable on this or not, what will you say? You'll say yes, because the degree of numerator is 1, denominator has 2 degrees. So I can write this as a upon y plus 1 b upon y plus 4. Same thing, just directly apply shortcut of this, a into y plus 4 b into y plus 1. Here it is y. Okay, so putting y as minus 4, you got minus 4 is equal to minus 4 plus 1, minus 4 by 3. Okay, that's your b. Minus 4 minus 4 minus 3, negative cancel, b is 4 by 3. And putting y as minus 1, you will get minus 1 here, so minus 1 upon 3, that's your a. Okay, so a is minus 1 by 3, b is 4 by 3. Okay, so rewriting this question, let's write here first. So this expression actually is going to be looking like a is minus 1 by 3, so minus 1 by 3 upon y plus 1 plus b is 4 by 3 upon y plus 4. What was actually y? Y was x square, na? So let's get back to the original question, replacing this, because this was under the integration, but remember integration was with respect to dx. So let's first of all replace y with x square. Okay, so this becomes minus 1 by 3 x square plus 1 plus 4 by 3 again x square plus 4. Okay, so this question here is actually this in two parts. I think you can solve this, because now you have to integrate with respect to dx. So now copy this and let's solve it. Okay, so minus 1 by 3 as it is, integration you have to do now. What is integration of x square plus 1? Tan inverse x by or x by 1 plus again 4 by 3 1 by a, na? So this is again x square plus a square. Okay, a square was 1, a was 1, a square is 4, a is 2, so 1 by a for this, so 1 by 2 tan inverse x by 2 plus c. So minus 1 by 3 tan inverse x plus 2 by 3 tan inverse x by 2 plus c. Okay, the last step is not typical. It's the idea that if it was only y, we would have done partial fraction and then replacing y with x square again. We are not doing substitution, we are just assuming it for time being, so we can apply partial fraction. Okay, all right. So okay, let's look at one of the most important variation. Slightly typical because you can see what is there now, trigo, and you'll think how do we know it's a partial fraction or anything? Of course you don't know, you don't learn something like this. You understand this and then apply this. The moment I see this, I see 3 sine minus 2, 5 minus cos square 5, 4 sine. Denominator is also complicated, numerator is also there. Sine and cos both are present. But if we look at the simplest term, that is cos phi sine phi, cos phi d phi, that gives me the idea that I should take, let sine phi as some substitution t. Okay, then differentiation of this is cos phi d phi. Okay, that's present here, dt. Okay, so this is the substitution we need, so let's use it. So integration 3 sine phi, that means 3t minus 2, then dt, and denominator is 5 minus cos square. Now what is cos square? Cos square is 1 minus sine square, that means 1 minus t square, minus 4 sine phi means 4 sine t. Okay, now let's readjust and see what is the expression here. 3t minus 2, this becomes plus t square minus 4t minus 5, okay, dt. And linear upon quadratic it is looking like, but before applying directly linear upon quadratic, see if you can split the quadratic in the denominator. If the quadratic, I'll give a note here, if the quadratic can be splitted, then use partial. Okay. If the quadratic can't be splitted, not splitted, then use perfect square method. Okay. This will help you to identify, because if the same question I was discussing in this last exercise, I would have said this is linear upon quadratic and solve it. Okay. But now I'm saying don't use that. Why? Because partial is a better option. So let's see first of all whether we can split this or not. This is splittable. This is t minus 5, t plus 1. Okay, and again same idea. Numerator degree is 1, denominator degree is 2. Partial fraction is applicable. So I can write this as a upon t minus 5 plus b upon t plus 1. Okay, and if I integration dt. Okay, I'll put the value of a later here. Let's do the partial fraction here. 3t minus 2 upon t minus 5 t plus 1, a upon a into t plus 1. Okay, I'm taking LCM, plus b into t minus 5 upon t plus 1 t minus 5. So cancel the denominators and shortcut. Put this time t is there, so put t as 5, put t as then put t as minus 1. So t is 5, so 5 3 15 minus 2 13 is equal to a into 6, so a is 13 by 6. Okay, is there some mistake? It is coming such a weird value. Oh, okay, we missed this. 5 minus 1 was actually 4, not 5. That's why. Interestingly, still it was splittable. So this is 4. So I'll have to redo all the steps here. The reason I knew this, because I've done this question a lot of times, so I knew that the answer was a and b was very good values. All I remember that. Okay, so now this is 3t minus 2, and if we split the denominator, this is nothing but if you look at directly, this is t minus 2 whole square. Now partial fraction is applicable to whole squares. It's just that what do we have to do? We'll have to write this as 3t minus 2 upon t minus 2 whole square. Whenever square is there, whole square is there, you write this as a upon t minus 2 plus b upon t minus 2 whole square. You have to write both the terms. And now use LCM. So a into t minus 2 plus b upon t minus 2 whole square, t minus 2 whole square, 3t minus 2. This cancels it, t minus 2, t minus 2. Put the value of now t, putting t as 2. Okay. It will generate 0. So 3 into 2, 4, 6 minus 1, 4 is equal to b directly, because a term will be 0. And next you put t as anything, okay, because there's no way you can make b 0 and you'll get the value of a. So put t as 0. If you put t as 0, we get minus 2 is equal to minus 2a plus b. Okay, and b is already 4, so minus 4 minus 6 is minus 2a. Now we're getting good values of a and b now. So a is 2, b is a is 3, b is 4. Okay, so let's come back to this integration now. So I can rewrite this as integration of a upon t minus 2. So a is 3 upon t minus 2 plus 4 upon t minus 2 whole square. Okay, dt. Now we can do the integration also. So integration of this is 3 log mod t minus 2 plus 1 by x square integration minus 1 by x. So 1 by t minus 2 whole square integration minus 4 as it is, 1 by t minus 2, and the coefficient of t is 1, so we don't have to worry, plus c. That's your answer. Okay. What was t? We forgot to put t now. What was t? Sine phi. So yes, 3 log sine phi minus 2 minus 4 sine phi minus 2 plus c. Okay, in the bond. All right, last question. Last form as such. There's one more variation I know. This time, see, we have a linear expression in the denominator. We have a quadratic which cannot be splitted. Okay, so partial fraction cannot be done so easily on this. Also, partial fraction is whether applicable or not. Degree, numerator is 2, denominator is, this is 2 and this is again multiplied by x, so degree highest power will come 3. Degree is highest power. Format. When you have a quadratic factor in it, so you do the partial fraction of a upon x minus a, that's normal. It's not a problem. It's just that whenever you write the quadratic factor, you write bx plus c, cx plus d, ax plus b, something like that. Means you write a linear expression on top of a quadratic part. You can split this about linear and quadratic. So linear a upon x minus a plus bx plus c upon the quadratic. Remember that. So now let's use it. Rest all the partial fractions are very straightforward. It's just that this one is a upon x plus 2 plus bx plus c upon the quadratic x square plus 1. Now you have to find ABC. So let's solve. A into x square plus 1 plus bx plus c into x plus 2 upon same x plus 2 x square plus 1, here it is x square plus x plus 1 x plus 2 x plus x square plus 1. Denominator cancels, apply the shortcut, put x as something which makes 0 factors. If I put x as minus 2, you can see, put x as minus 2, what do you get? Left side you get 4 minus 2 plus 1 is equal to, this is minus 2 square is 4 plus 1, so 5a basically, and this whole thing will become 0, so this is coming out to be 3 by 5 is your a. Next you put can we generate 0 now? No more zeros can be generated, so directly put x as 0. Let's see, the benefit will be this term, this will b will become 0 this time at least, so you'll get the value of c. So let's put x as 0, so 0 0 and 1, so left side is 1 0, so a, this is 0, so c into 0 plus 2, that's 2. A you are already calculated 3 by 5, so 1 minus a will be 2 by 5 is equal to 2c, so 1 by 5, c is coming 1 by 5. Rest remain b. Now you put any other value of this, any other value, put x as 0 is done, minus 2 is done, so you can put anything. I'll put 1, let's see, so 1 square 1 plus 1 3 is equal to a into 1 plus 1 2 plus b plus c into 1 plus 2 3. You have the values of a, b, c. Solve for b. 3 is equal to 2a plus 3b plus 3c. b is equal to 3 minus 2a, so 6 by 5 minus 3c, 3 by 5, that's 3b basically. So 3b is coming 5, 15 minus 9 is 6, so b is coming 2 by 5. We have found ABC. Okay, let's copy the question, let's solve it now. So I can rewrite this as a was 3 by 5, okay, upon x plus 2, then there was the partial fraction was bx plus c upon x square plus 1, so b is 2 by 5, sorry, 2 by 5 x plus c is 1 by 5, okay, upon x square plus 1 dx and the integration. So the first part is very simple, 3 by 5 log mod cos x plus 2, 3 by 5 log mod, sorry, by mistake second cos, this will be log mod x plus 2 plus, I can take this 1 by 5 outside because it's creating a problem right now, 1 by 5, this is integration of, still left with 2x plus 1 upon x square plus 1 dx. Okay, even after partial fraction, still it's a lengthy question, so the chances of this coming directly in exam very rare. I'm not saying it cannot be there, but it's very rare, very rare, because it's extremely lengthy. Plus 1 by 5. Now what you do is you split this about this plus sign, so integration 2x upon x square plus 1 plus 1 upon x square plus 1. Okay, 1 by 5 is outside dx, and I think now you can do this easily, 2x dx, and this is again integration. This is standard form tan inverse, and this is t dt substitution. So you can solve this, copy the same expression, plus 1 by 5, 1 by t integration is log t, so log mod x square plus 1 directly, okay, plus this is 1 by a 1, so tan inverse basically. Okay, tan inverse x by 1, so x plus c. So that's the whole answer. 3 by 5 log mod x plus 2, 1 by 5 this, and then 1 by 5 tan inverse also. All right, we're done with this. Okay, now let's discuss some tricky questions. Look at this question. You have to integrate this dx. Okay. I'll generate only the partial fraction form because the task is to understand how this is a partial. Rest, I think we have covered all forms. Now you can practice for the remaining questions. Okay. So this is cos x upon 1 minus sin x, 2 minus sin x. The problem is trigo is there. But if you see cos x dx, you will understand clearly sin x should be t. So cos x dx should be dt. Okay. If we use this substitution, numerator becomes dt, denominator becomes 1 minus t, 2 minus t. Okay. So what is this? We take negative common from both the expression. This is nothing but 1 upon t minus 1, t minus 2. A simple partial fraction question. One second. T minus 1, t minus 2 dt. So you do the partial fraction like a upon t minus 1 plus b upon t minus 2. Find the value of a and b and integrate. If you do the integration, it will be log. Okay. They are actually very simple. Okay. It will come a into t minus 2, b into t minus 1. I think you can solve this very easily. Put t as 2, you get 1 is equal to b, and put t as 1, you get 1 equal to minus a. So a is minus 1 basically. Okay. So basically this integration becomes integration of 1 upon minus 1 upon t minus 1 plus 1 upon t minus 2 dt. So that is integration minus log t minus 1 mod log t minus 2 plus c. Combine it, log a minus log b, log a minus log b plus c. So this is log mod sin phi minus 2, or sin x was there, no, sorry, sin x minus 2 upon sin x minus 1 plus c. Okay. All right. Next question. Integration of this. But before even starting the question, first of all, is partial applicable? No, because denominator has x square plus 1, x square plus 3. So we have done this kind of question if only x square was y. But the problem is numerator is not, there is no x square. So we cannot assume x square as y, because this will create a problem, no? This x. So now try to think of substitution. What do I take x? What do I take as t so that 2x dx is generated? If I take x square as t, 2x dx is generated dt. I think it's understandable now. This becomes integration dt upon t plus 1, t plus 2. Same kind of question. Write down a upon t plus 1, b upon t plus 2. Okay. Solve the partial fraction, get the integration. If you put yes, t plus 2, t plus 1, no? So this will be, a will come 1 and b will come minus 1. Minus 1 t plus 2 plus 1. This will work. So basically this is integration 1 upon t plus 1 minus 1 upon t plus 2. Okay. The point is they are very simple terms, so I have done them mentally. You can do normally partial fraction. I would have taught you. Okay. So t plus 2 minus t minus 1. It's generating. Okay. So integration is log t plus 1. This will be log t minus 2. So upon t plus 2 in the mod plus c, and t was x square. So log mod x square plus 1 upon x square plus 2 plus c. Okay. Okay. Done with this. Let's look at this also. Kind of a cute question. It looks very simple. Means if we have not been discussing topic wise integration, you would think this is a very simple question. Although it is, I'm not saying. It's just that you'll never take this for a partial fraction question. You cannot see this as a partial fraction question. Let's see. Dx. You cannot use substitution, because even if you take e raised to power x minus 1 as t, there is nothing present here to do the substitution. Okay. But that's the point. This question works on this idea. Yes, you by force take e raised to power x as t. Let's see what happens. Then differentiation is e raised to power x dx is dt, but e raised to power x is not here. So fine, we'll provide it, e raised to power x in multiplication and in division. Okay. So if we force this, we can see now this is our dt. And what is our denominator looking like? Numerator becomes dt, denominator is e raised to power x is t, so t minus 1 into t, or I'll write t first, t into t minus 1. This can be done by partial fraction, a upon t plus b upon t minus 1. Do the partial fraction of this, so you'll get same idea. Okay, take the LCM and put the values of t. You will get a as, I think, minus 1 and b as 1 this time. 1 upon t minus 1 minus 1 upon t. This will work. So this becomes integration minus 1 by t plus 1 upon t minus 1 dt. So this is minus log mod t plus log mod t minus 1 plus c. So it becomes log t minus 1 upon t mod plus c. What was t? E raised to power x plus c. Okay. So good question. Not that tough, but yes, good question. Okay. look at this last question. Okay. Again, kind of look like partial, but the form should be either like x into x plus 1 x plus 2 type thing like this, or a quadratic, not power n. We cannot deal with this. We cannot directly say it is a upon x plus v upon x raised to power n plus 1. We cannot write this. This is incorrect. Okay, so what do? We'll take x raised to power n as t. Let x raised to power n as t. Okay. Then differentiate n x raised to power n minus 1 dx as dt. Okay, let's see what substitution results in. So let's see, integration dx. So integration, there is nothing present with 3x, so how will we do the substitution? We'll force it. Okay, so 1 upon x raised to power n is t plus 1, dx is dt upon, if I generate dx from here, I get dx is dt upon n x raised to power n minus 1, n x raised to power n minus 1. Okay. Look at this. If we combine x and x raised to power n minus 1, okay, it becomes x raised to power n, and what is that? T. So basically 1 upon n is constant, so let it be outside, and these two combined becomes x raised to power n, so basically t into t plus 1. I think we have solved this question same over here. A upon t, b upon t minus 1. We'll copy this, log t minus 1 upon t. So this again you can do it by partial fraction, a upon t plus b upon t. I think this is minus 1, so this is plus 1, so slightly different. For this, bigger is this, smaller. So a should be 1 and b should be minus 1. Okay. You try to subtract this, so t plus 1 minus t, it will get 1. Okay, this is how I mentally do this, because the values are very simple enough, so that's fine. Otherwise, if the values are complicated, you have to use the proper method. Okay, so this becomes 1 by n integration 1 upon t minus 1 upon t plus 1 dt. So 1 upon n log mod t, and this will be negative of log mod t minus 1, so a minus b is log a by b plus c. So 1 by n log mod is x raised to power n upon x raised to power n plus 1 plus c. Okay, that pretty much summarizes your partial fraction. Okay. Rest the upcoming topic we'll do in the next class. Okay, the class is done. We'll see you in the next class. Good day, everyone.